Hey everyone, hope you're doing well today. Welcome to part 1 of the macOS Command Line Essentials video series, where I'll be teaching you the knowledge you need to know to start using macOS's command line interface effectively for your everyday work. Before we get started, we're going to install a few pieces of software that will make the command line a lot more user-friendly. So the first is a program called iterm2. I'll go into the details of what iterm2 really is in a bit, but for now, let's just download this piece of software and install it. So we go ahead and click the download button, and it should download this zip file. We extract the zip, and then we drag the iterm application into our applications folder. We'll then open it up, right click and open. And follow the instructions for installing dependencies that we need to install, such as pip3. Now that the software is installed, we can go on into installing the next piece of software, which is called Homebrew. So Homebrew is a package manager for the macOS command line, and I'll explain what that is as well later. But for now, all we need to do is copy this command, which they have this helpful clipboard button, which will copy this command into our clipboard. And then we can just paste it into the iterm window that we had just opened and hit enter. Then we will have to enter our password. And then hit enter one more time to start the installation process. So the installation has succeeded, but we still need to finish the installation process by running these two commands. So we'll copy them into our clipboard and paste them. And there we go. We will have successfully installed Homebrew, which we can test out by typing brew -- version. Before we move on, I want to address the question, what is the shell or terminal or command line? So there are two common ways of interfacing with your computer. The first that everyone should be familiar with is the graphical user interface, abbreviated GUI and actually pronounced GUI. But a second way is a text-based interface called the command line interface, or CLI. We can access the command line interface using programs called terminal emulators. This naming goes back to when we had room-sized computers called mainframes. And in order to use the mainframe, a user had to sit at a physical computer-like device called a terminal that consisted of a screen, keyboard, and just enough memory to store a screen full of text. The terminal was so named because it connected to the terminal end of a network cable where the other end was connecting to the mainframe. And therefore, since we no longer have mainframes and terminals, but the terminal was how we accessed the mainframe with a text-based interface, these programs are now called terminal emulators. So macOS comes with a built-in terminal emulator called Terminal, but what we just installed is a program called iterm2, which is a more feature-filled terminal emulator and generally makes the process of working with the command line a lot more enjoyable. So what about the shell? Well, the shell is a program that allows the user to interface with services provided by the operating system. So you might not have thought too much about the operating system, but the operating system actually provides the core functionality of your computer, like the file system, network connections, as well as process management, which lets you use multiple programs at the same time. And the shell is the way that you can interface with these services. So the shell can be run in two different modes, interactive and scripting. And when you open a terminal emulator, you'll launch a shell in interactive mode, but we'll see later on, the shell's scripting mode is very powerful as well. So a final word on terminology. When we use the shell, we're often referring to the shell program itself. Whereas when we say a shell, we're referring to a running instance of that shell program. So all the terms we just discussed are often used interchangeably, even if pedantically they have slightly different meanings. So here are just 4 examples of what people often say, and they can all be considered correct. So we might open up the terminal and type some commands, or we might use the command line to perform some action. We're going to open up a shell and again run some commands, or we might type the following command in the console, which refers to the terminal emulator. So all of these terms are often used interchangeably. We've talked about the shell as an abstract piece of software, but now we're going to introduce 2 actual shell programs that are commonly used. So the first is called Z shell, and it is the default shell that it comes with macOS. But an older and widely used shell, often on Linux servers, is called bash, which stands for the born again shell. It is the default shell of most Linux operating systems, and it got its name as it was a free software replacement of the Bourne shell used in Unix. So as discussed previously, shells can be run both interactively and in scripting mode. And therefore, Z shell and bash are both full-fledged programming languages. However, Z shell is often only used interactively, whereas bash is used in both interactive and scripting mode, and most shell scripts are still written for bash. So another phrase that you'll often hear is that macOS is a Unix-like operating system. So Unix was an operating system developed at Bell Labs, and Unix was one of the most elegant operating systems ever written. It had a modular design where it consisted of many different tools, each one doing one specific thing well, but they could be combined together in order to perform the complex tasks necessary of an operating system. Unix also adopted an everything is a file philosophy, where every feature of the operating system, such as processes, network connections, input devices, output devices, were all represented internally as a file. This introduced a very uniform interface for the different parts of the operating system. Another feature that's often borrowed from Unix is its file system hierarchy standard. At the top of the file system is a directory called a root, and there are commonly shared directories such as etc, lib, user, and var. Within each of these folders are files that have a particular function. So within etc, configuration files are often stored, lib, libraries that are used by different pieces of software, user, the user-specific programs, and var, files that are often changing, such as log files. So because Linux is also a Unix-like operating system, macOS and Linux often have similar inner workings. Throughout this tutorial, many of the commands we'll discuss will work on both Linux and macOS, but because they are still different from each other, not all the commands will work. Before you type any commands, you will be greeted with a command prompt, which gives you information about the current state of your shell. The command prompt provides information such as your username, the name of the computer you're currently using, your current working directory, as well as a % or a hashtag. The % sign means that you're using the shell as a normal user, whereas a hashtag means you're logged in as the root user. You generally won't ever need to use an interactive session as root, because you can always execute commands that require additional privileges using the sudo command, which will be discussed later. So every command follows this general syntax. We'll have the name of the command, followed by optional flags, and then any arguments that need to be provided to the command. So here are some examples. So we have this copy command. We gave it a -a flag, which informs that it's not copying a single file, but instead a whole directory. And then we need to supply the source directory as well as the destination directory. For the second command, this list command, we don't have any arguments, but we have the command itself, as well as options to the command, so -la. And finally, we have a command that doesn't have any flags, but takes in required arguments. So make the directory called my_new_directory. So as we see, the command is separated using spaces. And therefore, if we have arguments that contain spaces, the argument either needs to be surrounded by double or single quotes, or we have to escape the spaces. The difference between double and single quotes will be discussed in 2 slides. But for now, just know that if we have, say, a file name with spaces in it, we can surround it with double quotes or single quotes, or we can add backslashes to escape the spaces. So what do we mean when we have to escape characters? Well, some characters have special meanings to the shell. So for example, the space separates the command from its flags and arguments. Single and double quotes indicate the start and end of a string. The asterisk matches any number of characters, including none. And the question mark matches any single character. So since these characters have special meanings, when we want to use the literal meaning, we have to use the backslash character to escape the character. The backslash is also used to give special meanings to otherwise literal characters. So the 2 most common examples you'll see are \n, which starts a new line of text, and \t, which represents a tab character. The final features of the shell that you should be aware of are variables, string interpolation, and substitutions. Variables are essential when we use Bash as a scripting language, and we can define variables using the equal sign. So here we have 2 examples. We defined a variable called myname and assigned it to the value of Matt. And here we defined a variable called output_dir and assigned it to the value of /users/matt/downloads. And then to use these variables, we can perform string interpolation. Interpolation and substitutions require that we use double quotes because single quotes do not perform interpolation. And when we are accessing a variable, we have to preface the name of the variable with the $sign symbol. So here, the echo command just prints out a string of text to our terminal window, and we're going to echo the value of the home variable with this command. We can also perform parameter substitution, where if the variable is not defined, we can print out a default value. So here we have echo hello myname, and since myname is defined, this will actually output hello Matt, whereas the second command, since the variable name is not defined, will print out hello world. Lastly, we often want to use the results of a command in our later command, and we can do this with something called command substitution. So here we want to store results in a directory called results, but also provides information about when this directory was created. And we can do this by leveraging a command called date, which prints out the current date and time. And then we will use the output of that command and substitute it into this make_dir command. So the result of this will be a directory called results dash the time that this command was run. So that's it for part 1 of this macOS command line essentials series. It was a lot of theory, but it should set us up nicely for the following parts, where we're going to jump straight into learning commands that are used most often in everyday work. So hope to see you there.